Okay, at the moment this is an algebraic example. It's an example on the instantaneous center of zero velocity. The bar of length L and angle theta at an angle theta with the vertical theta with the vertical, and its lower end A has a speed VA directed to the right. Determine the angular velocity of the bar and the velocity VB of its upper end B at the instant depicted. Okay, the first step, so step 1, is to isolate the bar. So we want to have a rigid body just of the bar. So we know that at the instant depicted, this is theta, and this is our V of A, and our V of B is downwards. And that angle in there is theta. So what we do is we note that velocity is perpendicular to the center about which it rotates. So if this velocity A is rotating about a center, the center is in this along this plane, and if this velocity B is rotating about a center, it's along this. Now the instantaneous center is where these points meet, and that point is just here. So that instantaneous center is there. So the angular velocity is about this center. So the next thing we want to do is find the intersection point, the instantaneous center of rotation, and we'll say that the velocity at A is the magnitude of the displacement. So AC, or say we'll label this point C, and this is A, this is B. So A is the magnitude of AC. So AC is the angular displacement. So the angular velocity times that linear displacement is our velocity of AC. So the velocity of A, just use scalar quantities here, the velocity of A is equal to the angular velocity multiplied by the displacement. So we can find our omega, so angular velocity, in terms of velocity and displacement. And we can then see, so L cosine theta by alternate angles is our displacement. Because if we do alternate angles, this angle in here is also theta. So L cosine theta gives us this displacement here. So that's V of A on L cosine theta. And that's going counterclockwise by the right hand rule. Our omega k cross r negative j is I. So this is traveling in the I direction, so that's what we want. So it is going counterclockwise. We can then find our velocity of B in terms of velocity of A, and that's what's asked for in the question. So V of B, so the V of B is equal to the magnitude of the displacement, so BC multiplied by our angular velocity, which is L sine theta. So this is our displacement here. This displacement, which is, so this displacement here from this center point to the velocity is this BC term. So our angular velocity is VA on L cosine theta, but we're going to say that BC is L sine theta because that's what this is represented by. So L sine theta omega, and that is equal to V of A times V of A tan theta, because the L terms cancel out. Now, if we were to represent this question with an angle, say theta is equal to 30 degrees, and our length is, say, 5 meters, all we would have to do is substitute those values back into our algebraic expression. So, say we let the velocity, the length of A, the length equal 5 meters, and the velocity of A equal 3 meters a second. That's all we need to determine what, and also our angle, theta equals 30 degrees. So that's all we need to determine our velocity at B, or velocity of B, and our angular velocity. And we can also determine our length BC in terms of these quantities. Okay, so first of all, we'll find our different lengths. So AC, we found before, was L cosine theta. So L cosine theta is 5 cosine 30 degrees. And we'll leave that in terms of that 30 degrees. And our BC term is 5 sine 30 degrees. And we know that sine 30 is equal to half, so this is 2.5 meters. And this term in here is, actually we'll express it as a number, so it's 4.33 meters to 3 significant figures. But we just shove that in the calculator, leave it in the calculator so that we can be more accurate when we go to solve the question finally. Alright, so our equation for angular velocity was v of a on AC. And we know what our AC term is, we know what our v of a is. Our v of a was 3 meters a second, so our angular velocity omega is equal to 3 over 5 cosine 30 degrees, which is equal to 0.69 radians a second. So the next thing we'll do is to find our v of b. So v of b equals bc omega, which equals 2.5 times this value. So 2.5 times, our answer is 1.73 meters per second down. Okay, that's all we need to know for this question. We've expressed it in terms of our angular velocity, so our omega term was here. And our linear term, so velocity of b, is here. And we've shown that using the algebraic term just allows us to substitute in values such that we only need a certain amount of variables to find what our answer is going to be. Okay, thanks for watching.